IUPCA, representing International Union of Pure and Applied Chemistry, is located in São Paulo, Brazil. The IUPCA is a group that is responsible for development of the standard of naming chemical compounds. As we know, the chemistry is divided in organic and inorganic. In the field of organic chemistry, we find the hydrocarbons. Hydrocarbons are organic compounds that made of only carbon and hydrogen. Is the structural base of organic compounds. Carbon can share electrons with other atoms, results in hybridization. Hybridization is a phenomenon that consists of mixing of atomic orbitals to generate a set of iron orbitals, which are sp, sp2, and sp3. All these orbitals are identical but vary in their orbitals. And so the importance of classification of hydrocarbons and their rules is so important. The hydrocarbons are separated in different groups. Saturated hydrocarbons, in this group we can find the alkanes that are atoms with simple bonds. The other group is unsaturated hydrocarbons. In this group we can find the alkynes with double bonds, the alkenes, triple bonds, and aromatics formed benzene rings. The most common hydrocarbons are methane, butane, ethane, propane, peptane, ethane, and ethane.
Hydrocarbons. Hydrocarbons are organic compounds that are made of only hydrogen atoms and carbon atoms. Classification of hydrocarbons. Saturated hydrocarbons have as many hydrogen atoms as possible attached to every carbon. Unsaturated hydrocarbons have double and triple bonds between some of the carbon atoms. Aliphatic hydrocarbons are compounds of hydrogen and carbon that don't contain benzene rings. In the aliphatic hydrocarbons, there are many types that are alkanes, alkenes, and alkynes.
Alkanes are hydrocarbons because they are made of only carbon and hydrogen atoms, and they are unsaturated because they have one or more double bonds in their chemical structure. The UPAC rules to naming alkanes, the main chain of carbon atoms must contain both carbons in the double bond. The main chain is numerated so that the double bond gets the smaller number. Before the root name, the number of the carbon atom at which double bonds start in the smaller number is written. If more than one double bond is present, the prefix D, 3, tetra, etc. are used before the in, and strangely, the letter A is A after the prefix for the number of carbons. And alkenes are chemical compounds that have triple and double bonds in their chemical structures are referred to use unsaturated because alkenes have triple bonds in their chemical structure and consist of carbon and hydrogen atoms. They are unsaturated hydrocarbons. The steps to naming in the UPAC rule an alkene name the main chain, find the longest continuous chain of carbon containing the double or triple bond. The names of alkenes end with -ine. When there is more than one multiple bond, use numerical prefix diene, diene, triene, triene. Step 2. Number the carbon atoms in the main chain, and finally the step 3. Write the full name, assign numbers to the branching substituents, and list the substituents alphabetically. Alkanes are chemical compounds that consist of carbon and hydrogen, so alkanes are chemical compounds that consist of carbon and hydrogen atoms, so they are also called hydrocarbons. The chemical structure of alkanes only consists of single bonds. The UPAC rules of naming alkanes, unbranched straight-chain alkanes indicate the number of carbon atoms in the chain with a prefix followed by the ending "-ene". Branched chains alkanes identify the longest chain of carbon atoms. This parent chain provides the root name, for there are two or more parent chains of identical length. Choose the parent chain with a greater number of substituents. Identify the name of substance, number the parent chain, one substituent number from the end that gives the substituent the lower number. Use a hyphen to connect the number to the name. Two or more identical substituents number from the end that occurs is gives the lower number of substituents, and contrast first number of times the substituent occurs is identified by a prefix D, tri, tetra, penta, hexa, and so on. A comma is used to separate position numbers. Two or more different substituents list the substituents in alphabetical order, and number from the end that gives the lower number to the substituent, and correct first if there are different substituents in equivalent positions at opposite ends of the parent chain. Gives the substituent of lower alphabetical order the lower number prefix, such as D, tri, tetra, penta, hexa, and so on, are not included in alphabetizing. Cycloalkanes prefix the name of the corresponding straight chain alkane with cyclo. Identify and the name substituent on the ring. Number the ring. Once substituents, no number necessary. Two substituents numbers so that substituents with lower alphabetical order give lower number. Three or more substituents number in order to give the substituents the lowest. Aromatics. Aromatics are an organic compound that consists one or more benzenes or equivalent thereafter on cycle rings. For substituent aromatics. Aromatics are an organic compound that consists one or more benzenes or equivalent thereafter on cycle rings. The usual rules to naming an aromatic are: for substituent benzene rings where their substituent contains more than 6 carbons, the benzene ring is not by using a pentyl prefix on the alkane name. For substituents benzene rings where the substituent contains less than 6 carbons, the alkyl chain is added as a prefix with the ending changing to "-ile". For benzene rings with multiple substituents, the ring atoms are numbered to minimize the numbering of the substituents groups. Alternatively, ortho-meta-para nomenclature can be used for the substituents ring.
So let's begin to name an alkane. As we know, an alkane have only single bond and this have single bond. So let's identify the main change of carbons. That is this. Here we have 1, 2, 3, 4, and 5 carbons. And so this is a pentane. And in the second carbon, we have a methyl group. So it is 2 methyl pentane. This is the full name of this compound. So let's start to name an alkene. As we know, an alkene have double bond that is here. Now at first you need to identify the main change of carbons, that is this. Here we have 1, 2, 3, and 4 carbons, so is butane. And here we have the double bond that is in the second, the carbon that is 2 butane. And the carbon number 2 and 3, we have a metal group. So it's 2, 3, metal. The metal, because we have two metal groups, the metal. So the full name is 2,3-dimethyl 2-butane. So let's begin to name an alkene. Identify the main change of carbons, that is this. It's a linear. And here we have 1, 2, 3, 4, 5, and 6 carbons. So it's an hexene. And as we know, an alkene have triple bond that is in the carbon number 2. So it's 2-hexene. And here is the full name of this compound. So let's begin to name an aromatic compound. This is a benzene because we have 6 sides. And this is a bromine. We have 3 arms of bromine, so is brom, and we have 3. And say 1, 2, and 3. 1, 2, and 3. So this is the full name. 1, 2, 3, 3 bromine benzene.
Conclusion. In this work, I could observe the importance of the correct form to name hydrocarbons and its rules.
I learned what are hydrocarbons, the types of hydrocarbons, and how they are composed.
The organic compounds are very important in our daily life because a lot of things are made with these compounds. So in this video we'll learn how to number 8 compounds and their characteristics.
The hydrocarbons are compounds formed by hydrogen and carbon. There are different classifications of these as are alkanes, alkanes, alkenes, and aromatics. They are also very important for us as we can use them in gasoline, for jets, oil, and other things. Hydrocarbons are of great importance for our daily lives, as these are used in fuels in internal combustion engines. In addition, main alkanes are good solvents for non-polar substances. Hydrocarbons of high viscosity liquids and are part of diesel and jet fuel. This is how they are very useful for us.